what is thermal oxidation and what is the difference between thermal oxidation and the CVD process, the differences. Okay, and remember for thermal oxidation, the oxygen has to diffuse through the silicon oxide layer you formed and then reach the silicon oxide and silicon interface and react with the silicon. Okay? And the thermal oxidation typically happens at pretty high temperature. Okay? Remember, so in order to have the silicon oxide formation using thermal oxidation, you must have a silicon layer there. You cannot use thermal oxidation process to put a silicon oxide on top of a metal. You cannot, because you don't have even silicon layer there. How are you going to use a thermal oxidation to oxidize the metal? You cannot give you silicon oxide. Okay? And silicon oxide, the thermal oxidation typically the growth rate is very, very slow. Very slow. Temperature is high. Okay? And you cannot grow layer thickness more than 2 micrometer because it is very difficult for oxygen to diffuse a very thick silicon oxide layer and react with the silicon. Correct? And I don't know whether you have forgot this one. Do you still remember?
Yeah.
Do you still understand what I'm talking about? Yeah. That's very good. Okay, so in terms of thermal oxidation, we have Diel groove model. Okay, correct? This is the most famous one for Diel groove model. And so this is the tools configuration. I'm not going to test you this one, but you know that typically we have flow in the gas, okay, and the heating element, you have the chamber, and after reaction, you have to get rid of the byproduct, okay. And so the tool used for this thermal oxidation is actually called furnace, okay. Very special name for thermal oxidation is called furnace, and so. For thermal oxidation, we also have as I told you, when you do grow any material, you need to clean the surface. Especially for thermal oxidation, as I told you, when you want very high quality of oxide layer, okay, you want thermal oxidation. Okay, so in order to get high quality, you also need to have very good pre-growth method to reduce the contaminant. Okay, like we have RCA1, HFE, RCA2. So you don't have to remember all these details, but you have to know what are purposes of the three different the cleaning process. Okay, what are the main purposes? Okay, of course this one I don't have to emphasize anymore. I've already tested in your quiz. And here you have to know typically what is the temperature we use for the oxidation, okay? And the growth rate, you know how slow it is. You roughly know what is the range. Then when I ask you to make some decisions, you know how to make decisions based on this one. Of course, you don't have to remember exactly, okay, what is what 1 hour, how much. You know it's slow, okay? And you have to, of course, understand as I told you, you have to diffuse and react. Okay, understand the process and how it is different from the CVD process. CVD process basically happens right at the surface, but for this guy it's not. The oxygen has to diffuse the already formed silicon oxide layer and go into this interface and react. Okay, and because of this one, I talk about Diel groove model, correct? So this again for this one, you don't have to know the details from here to here, here, okay? But you have to know this one, correct? I told you the importance of this one. You don't have to know these details of this constant, but you have to know this equation. This equation basically gives you a Diel groove model, and of course this one you have to know. You have to understand. You have to understand the graph, okay? And also the long oxidation. What is the relationship? And short oxidation, what is the relationship of the thickness as a function of time? Correct? Diel groove model. and y is parabolic, y is linear equation, and in which regime is diffusion control limited, and in which regime is chemical reaction limited. Okay, for properties of silicon oxide, I talk about silicon oxide, you know, is amorphous, as I told you, correct? Silicon oxide is amorphous, and silicon oxide also typically have some stress. Okay, it could be tensile stress and it could be compressive stress, and the stress can be changed by using different recipes for the thermal oxidation process. Okay, and yeah, I told you I'm not going to test you this one, but actually it's very important for you guys to remember this one. What is the dielectric constant and what is the electric band gap of silicon oxide? Orientations, I say that no, correct? I said no. And so for this different oxide charges, you have to know, correct? So your oxide, what are the 4 typical oxide charges? And where is the location of them? Okay, where is the location of them? Okay, how we are going to reduce them? Okay, and what are the typical features of each one of them? This one you have to know. Correct? Okay, we finish this one. Second chapter.